Okay, hello, good afternoon, good morning to our West Coast folks. Thank you for attending. Today is our EarthScope Student Career Internship Summer Showcase. My name is Kelsey Druce, and I am the program lead. This is my third summer leading the Career Internship program. So this year we had 8 students participate in the program. They range from all the way from engagement to data services and in academic levels from community college to graduate students. So we're reaching a broad range of students and trying to work through the EarthScope system here to get them working with their projects and further our mission here at EarthScope. So we have students who worked on educational data and resources. We have science communication. We had interns working with the data services team on cloud, OnRamp, and developing some software and technical courses. And so they're going to give 5-minute lightning talks. Our first round is 3 interns, so they're going to go together, and then the rest of them will be 5 minutes after that. If you're not familiar with the program, it's 11 weeks plus, so a minimum of 11 weeks, but we have interns who stay on a little bit longer of full-time work during the summer. Typically, these interns are working remote as we are a remote first facility, but we have had interns work in person depending on the needs of the facility and your team and the interns. We do an orientation week. So they are, this year we were lucky enough to bring them to New Mexico. We were in Albuquerque and spent a little bit of time in Socorro doing a little bit of onboarding activities along with the Geo Launchpad and Recess interns. And so they were introduced to EarthScope. Bex gave them a nice warm welcome and some of the SMT staff, and they learned about what we do as an organization. Interns participate in weekly professional development workshops. So we did them bi-weekly this year. And the goal is to enhance their skills in communication and professionalism. So we invite guest speakers. We had a great presentation from our SciComm team. Chris Entemeyer gave a great presentation on resumes and CVs and a few other kind of professionalism tasks. So this program differs from Recess and Geo Launchpad in that this is not a research position and they aren't paired with mentors externally. They are working with EarthScope staff to further our goals here for the NSF NGF and sorry, NSF NGF facility. We are always looking for more mentors and more projects. There's lots of students who want to work with you. And so why should you participate? Well, you get dedicated support to help you complete some tasks and move some projects forward. Students often bring in new ideas and fresh perspectives. Interns become integral members of the team. And so it ends up boosting productivity and morale. And I think one of the best parts of this internship is that we are hoping to create a pipeline of intern to future employee. And one of the ways we've done this is through our application process now. If the one of the questions on the application is if you've participated as an intern before, and if you answer yes and provide the information that you did, your application gets reviewed on the rest of the pool. So if you have a project idea, please come talk to us. You could talk to me. You could talk to anyone on the internship team. And with that, we are going to move right into presentations. So we have 8 interns. We have a few talks that are, the first few are going to go together. There'll be 15, you guys have 15 minutes in the beginning, and then every talk will be 5 minutes after that. In the interest of time, we are going to not do questions in between presentations, but you are welcome to ask questions in the chat, and the interns will be monitoring those and respond as able. We're hoping that there will be a little bit of extra time at the end for some live Q&A as well. Okay, with that, we have Lexi, Kat, and Amanda going first.
Hello, I'll be sharing my screen for the 3 of us.
Okay, and this summer, Amanda, Kat, and Lexi worked with Scott and Emily, and our newest member of the SciComm team, Haley Bricker, who was a SciComm intern herself a few years ago. Okay, and you guys can take it away.
Awesome. Thanks so much, Kelsey. It's been really great working with the entire science communication team this summer, especially my fellow interns. We did a lot of work collaboratively, and that's why we're all going to present together. And I can't wait to show you guys what we worked on. So first up, I'm Lexi. I'm a PhD candidate at the University of New Mexico. And my focus for this summer was more on short form video and animation and to kind of get over my fear of Illustrator for things that are not just making a poster.
And hello, everyone. I'm Kat. I'm going to be starting my PhD at the University of Oregon next month. And my focus for the summer was written work. And I also wanted to get a bit more experience with graphic design and using Illustrator.
And lastly, I'm Amanda, and I just graduated with my master's from the UC Santa Cruz, and I'm currently starting a position as a seismologist in the Bay Area in September. My focus this summer was mainly on illustrations and visual storytelling using Adobe tools.
Sweet. So we're going to get started and kind of showcase some of our work for this summer. And I'm going to start off. So like I said, my two main goals were to focus on writing and then get some more experience with illustration as well. So my first project kind of combined the two, and it was a What is GPR page for the EarthScope website, which didn't exist before. So this involved learning myself about GPR and then creating a written page describing the technique, its uses, its limitations, and applications. And then I also took this great sticker that Emily had made and made it into two different graphics. So one kind of explaining how GPR worked, and the other one explaining some of the products that you might expect to get from GPR. And next slide. Awesome. And I also did some more classic news articles that are now up on the EarthScope website. So the process here was finding articles that are either connected to the NGF in some way and slash or just of general scientific interest, and then breaking those down for a general science interested audience. So the first one was focusing on using GNSS atmospheric delay to help improve short-term rainfall forecasting. And the second one was about how scientists are exploring the layer between glaciers and bedrock using ambient seismic noise. I'm actually staying on for another week, and I'm currently working on a third article about how scientists are using new methods to use geophysics to study whales. And next slide. Cool. And my biggest written project for the summer was an article for the Yellowstone Volcano Observatory's Caldera Chronicles, which is a weekly column just kind of describing the goings-on at Yellowstone. And as someone getting my PhD in volcanology, that's kind of a dream come true for me. And I focused on an article from an MSU researcher about the potential link between Yellowstone's earthquakes and its deep subsurface microbial life. We're talking like hundreds of meters below ground. And so this was a cool opportunity to work both with the study's author to make sure that the science was honored, but then also to make sure that it was broken down into an accessible way. And it actually went up this Monday. It was the most recent Caldera Chronicles and was picked up, as you can see on the right, by a lot of local and small news sources that reposted it, which is common for Caldera Chronicles, but was new for me. And in general, just getting this writing experience was really cool because it allowed me to delve into different topics. Like I said, my background is geochemistry, volcanology, and so I got to learn about microbes, glaciers, GNSS, and it was just a really cool experience. And I know that it's a bit hard to share written work in this kind of presentation format. So I'm gonna send a link in a group of links in the chat to my articles if anyone is interested in reading them. And then you can move on. I did some graphic work as well. I made two stickers. The first one honoring the Network of the Americas. And so this involved getting an updated list of station locations, putting it in QGIS, which was new for me. I have experience with ArcGIS Pro and Esri products, but QGIS was completely new, so that was cool. And then put it into Illustrator and created this kind of mission patch design with a little satellite swooping overhead. And this is the sticker format. And then I also created a simplified version to as a patch. So that's going to be an embroidered patch. And then, yeah, you can move on. My second sticker was a bit more analog. I like doing block print art, and I thought it could be something cool and different. And I wanted to lean into that rustic nature of the block print by doing this kind of nighttime mountainy scene. So this involved me drawing on this kind of rubber block, both inverted and backwards, then carving it out, inking it, stamping it like a big stamp, scanning it, and putting it into Illustrator to turn it into a cool new sticker. And then, Amanda, you can move on. The last thing that I'm going to talk about is this collaborative project with me and Amanda, which was super fun. It was our summer sketch series where we were breaking down papers, not in a traditional news article format, but instead as comics with captions for social media. And my part in this was the written part and breaking down the paper in the caption. And Amanda is going to talk a little bit more about the visual aspect. On to you.
Hello, everyone. And as Kat mentioned, this was so fun to work on together. And I worked on, as you'll see, a pattern throughout the summer, is a lot of illustrations. So these have been so interesting to me because EarthScope does such a wide breadth of variety in terms of instrumentation, experiments, and research. And so my goal here was to see how can we showcase this breadth of work in a way that anyone can understand and like just as a fun comic. So we did 3 of these and the last one was finished just yesterday. Here's the first one on how slow slip modulated low frequency seismicity. Here's our second one, our third one on determining rainfall induced runoff threshold with DAS. And we did one more, which is not on the slide. But you can see all of these on our Instagram, and they were so fun to work on. And within all the illustrations that I have worked on this summer, they were all using these 5 applications. And what I really want to share here is that illustration does not have to start with expensive $100 per month applications. Anyone can start. I actually, for the most of my illustrative career, I used Sketchbook, the pencil app there, which is completely free. And I used that for years before even moving on to anything that required payment. So if anyone is interested, I would recommend just downloading the Sketchbook app, which is free on any iPad. And tools like Illustrator and Adobe Express can really help you just like incorporate visual storytelling into your work that is already so important, but to help others also share the importance of your work. So some of the work that I have done this summer is stickers. I made a lot of fun stickers this summer. The first of all, this is a sticker called the Roadrunner, which is a portable toolkit for instrumentation that can be used for seismometers, GNSS, and a whole variety of things. And since it's called the Roadrunner, we have these cute little Roadrunners also in the figure. And it's a fun little sticker saying a weighted blanket is not enough. I want to be swept by the crust. So it's some silly stickers too. Something that I made very recently is for Kat's future upcoming whale article. I finished this last night. Just a happy little whale emitting a whale call that can be picked up by seismometers or DAS. So these kinds of fun illustrations is what I really was able to explore this summer. I also explored some writing, working on a seismology trifold. EarthScope currently already has a trifold given out to station hosts for GNSS stations, but we didn't have one yet for seismology stations. So what I was working on here is different illustrations and writing to incorporate into a new handout. So I made these 3 illustrations and then I wrote up some text to go into a new pamphlet to give out to station hosts for seismometers. And as you can see, you have my cover art on the front and some of my little illustrations in the back as well, along with all the text that I wrote up and edited according to information that would be helpful for our station hosts. Other writing projects I did is similar to Kat, working on the website educational pages. For example, I worked on what is seafloor geophysics, and I did this illustration for it. This is a very fun illustration where I got to work on all the little different instruments that go into seafloor geophysics. So as you can see, this was very, very fun. So then I wrote the article for it, and as you can see here, we have the article for seafloor geophysics, and I also wrote up the ERT page, although I didn't illustrate anything for it. So although my main focus was illustration, it was also so fun this summer to be able to dip my toes into things that I was not as used to. Moving on, another big illustrative project was collaboration with Lexi. So for this trading card project, we were hoping to create a set of trading cards that would be educational to work to use at conferences, classrooms. And the goal here was really to help convey how geophysics and the breadth of the functionalities, settings, and applications in which they can be used can really just be a mix of different instrumentations for different purposes. And Lexi will talk more about the details of the game itself, but these are 5 of maybe the 10 cards that I've illustrated so far. And you'll see we have a GPR, we have a satellite, we have an ocean seismometer, we have a drone, borehole strain meters, seismometers, GNSS. And here is what the cards will end up looking like. They actually are mostly done now, but they just haven't been put in the slide yet because we're doing some finishing touches on them. So, Lexi, take it away.
Yeah, so like Amanda said, we really wanted it to be not just something that was visually eye-catching, but also something that could help, especially students or people who may not be familiar with different types of geophysical research, understand how things come together to answer these type of scientific questions. So if it's inspired by the game Set, if you've ever played it, but there's cards in different categories. We have data cards, setting cards, like your field site cards, instrumentation, and like an application. And so the idea is that you can put together different cards to design your research project. And if the other players agree that your research project is good, then you get a point for your research project. So it's supposed to be that you can mix and match different instrumentation with different settings. And especially in a classroom setting, you could, go on the computer and do some research. What instruments are used at these settings? How do we monitor volcanoes, for example, to try and come up with a logical research project. So I'm really excited for that. I also did a little bit of work of graphic design. So the first thing I didn't do this original illustration of the penguins. You may actually have a sticker of this. But I wanted to try my hand at animating it using some, just existing stuff. So I did this in Adobe Animate. So we have the penguin jumping down. It causes a little baby earthquake that gets picked up by the seismometer. And I also, in After Effects, changed out the logos so that it reflects both EarthScope and the NSF NGF. And then based on some stories from engineers and from the larger engagement team of having to kind of reinforce the instrument installs for risk of interested animals getting into the equipment and the wires, I drew this "Data is Delicious" cow sticker of the cow eating the little seismometer wires. I did a little bit of written work. So a few weeks ago, we pushed this article on a new install on the Cocos Plate on Cocos Island in Costa Rica. This station has been down since about 2020, and it's the only NOTA station on the Cocos Plate. So it's already receiving really interesting data. It's the only thing kind of tracking the motion of that plate as far as NOTA stations go. So you can also look at that article, which is live on the EarthScope website. And then I focused on some video. So I did one based on one of our sort of professional development sessions on science communication. We had to use this program that only let you use the 1,000 most common words. So if you typed something in and it didn't, the word was too complex, it would flag it and you'd have to change it. So all of the interns took turns writing a little blurb about their project. And I made these very simple animations, like the middle one that you're looking at here of one of the Geo Launchpad interns projects. And so these were uploaded onto TikTok and YouTube Shorts and Instagram Reels. And I also made sort of the start of a series, think of it as like the launch of a series called Crust Busters, which is like Mythbusters, but for myths about the crust. So those have also launched. And then we all worked together on the intern spotlights, which have been going out all throughout the summer. I had some prior experience with Adobe Premiere, so I did the first one and then wrote up the best practices so that we could all kind of learn peer-to-peer. And that was really fun to work on.
Yeah, this summer has really been a combination of learning different skills, but also getting to hone it on our own. And it has just been the most amazing experience to work with everyone and the team here.
Yeah, it was really cool, especially with the video. I had pretty much no experience with video editing, so very grateful to Lexi for the help. And it was really cool to get to learn about what other interns were doing as well and get to feature them. And so, yeah, thank you so much to our mentors, Emily, Scott, Haley, as well as Kelsey, and the rest of the internship team. and then just EarthScope and the NSF NGF in general for supporting this internship. It was an awesome experience.
Thank you.
Thanks so much.
Nice work and lots of work. You three were quite the productive team. Incredible. Okay, questions are welcome in the chat, but we're going to go ahead and move on to our next presentation, which is Asif. Asif, can you go ahead and share your screen? Thank you. Asif is a returning intern. Asif worked with EarthScope last year as a career intern, and so he was able to continue his work from last year and make it a little bit more productive this year. And so he worked with the Cloud OnRamp team with his mentors are Tammy and Sarah. So Asif, go ahead and take it away.
Sorry, I had a mishap. Just give me 1 second.
No problem.
Yeah, hi. My name is Asif Ashraf. I'm a PhD candidate from University of Oregon, and this summer I was one of the Cloud OnRamp intern. And before I dive into my contributions to this project, I just want to briefly outline the project itself. So, as you may know, EarthScope is moving all of its data and computing to the cloud. So, geophysics researchers can work now closer to the data. And the cloud platform is called the GeoLab, and the ecosystem works something like this. So, you have the custom environment that's your preferred like Python libraries, and then you have your science workflows or your code sitting in GitHub or GitLab. You bring all of this in the GeoLab, which has a lot of applications and functionalities that can help you to run these things. And then you bring in the data and the compute itself from the commercial cloud infrastructure. Because the data and the computer sitting close together, there are fewer download barriers and less local setup. And from my perspective, I think the cloud on-ramp project sits over here, which is like the students, the researchers, the other people who use the EarthScope data. They want to transition from traditional geophysics analysis to the cloud-based, like cloud native or cloud optimized geophysics analysis. And under this umbrella, the team is doing a lot of different things. But I'm just in this presentation, I'm just focusing on the workshop part of it and the documentation development. The documentation are about developing or reviewing user-facing materials that can help researchers or students to transition their entire workflow from a traditional perspective to a cloud-based perspective. So for workshops, it works something like this. So we, as a team, tested the workshop materials, the notebooks, the codes that the PI gave us, and we identified content or workflow issues within that or like code errors, and we send the feedback to the PI. We also reviewed the performance and usability for hands-on cloud exercises, like looking at the memory or the CPU or the throughput using Grafana dashboards. So our goal was to analyze that if the maximum amount of participants were to run those notebooks at the same time, would GeoLife crash or not? And based on that analysis, the team decided to increase or decrease the threshold of computing power in the GeoLab. And I just want to say, because of that homework we did, the two workshops that happened under my watch, the recent geodesy workshop and the MISPAS workshop, well, like they worked very smoothly during the time. And for the documentation part, so I was responsible for developing the seismic content. So the OnRamp team has defined seismic skill sets that needs to be demonstrated from like the cloud perspective. And they have divided those into different MVP levels. And I just took those seismic skill sets and tried to make a very traditional, very basic seismic workflow, but from a cloud perspective. So a common thread connecting all of these notebooks is that they show the researchers that they don't need to download the data anymore because the data is already living in the cloud and they're performing computation inside the cloud. They can just use the reusable metadata and processing recipes, and that make the seismic analysis easier to iterate, reproduce, or even scale. And so that was like the purpose of showing all these notebooks, that you can transform your traditional workflow to the cloud-based workflow, and it is better. Then one other my contribution is making the task notebooks, and this is a little bit derivative of my previous works here in EarthScope. And I made three different notebooks. So first one is a desk operation that shows the capabilities or the functionalities of the desk. Then in the desk application, I made a very simple seismic analysis pipeline. So you retrieve waveform, you do some pre-processing, and you pick like some sort of phase or P or S. I showed that because all of these waveform retrieval are not dependent on each other, you can parallelize all of those. And any like learners or any students that going through the notebook that can see that the parallel processing that is much faster than any serial processing. And in task scaling, I just showed that how you do that, like take that parallelization and really scale it. And I showed an example how to feed that into a convolutional neural network to make like a very basic ML-based PUF picker. Yeah, I think this is the end of my presentation, and I am very grateful to my mentors and the entire OnRamp team. I learned so much from everybody, and especially like the entire EarthScope. And yeah, thank you. I'm happy to take any questions in the chat.
Thank you so much, Asif. That was great. Next up, we have Eshanta Mishra. Eshanta is presenting to us from a conference that he's at right now. So thanks for making the time for us today. Eshanta worked with in a similar environment, but a little bit different, but with the Cloud OnRamp team with Sarah Wilson and Tammy Bravo. Go ahead, Eshanta.
Thank you, Kathy. So yeah, hi everyone. I'm the other Cloud OnRamp intern working with Asif, and my mentors were Tammy Bravo and Sarah Wilson. So my work this summer also revolved around GeoLab. So I'd like to start with an introduction of what GeoLab is. And to explain GeoLab, I'd like to start with an explanation of how things have been working traditionally or in a local workflow. So in a local or a non-cloud workflow, you start with a personal computer or a high-performance computer that is in your organization. You log into the computer, you fetch the data from some remote servers to your local machine. You configure all the software and environments that you need to run your geoscience workflows, and then you run your workflows locally. But in a cloud workflow such as GeoLab, the data, the compute, the environments, and the workflows all come in the same place. So everything is on the cloud. So what a user needs to do is just log in, and they can refer to some existing geoscience workflows that are already there in the cloud, or they can also create their own workflows and start from there. So my work this summer was developing parts of GeoLab, and I started with creating instructional notebooks. So I was able to create 5 instructional notebooks, and I started with creating a template that everyone can follow to create notebooks within GeoLab. And then I created notebooks that explain the basics of GNSS data and teach the user how to use the EarthScope software development kit or the EarthScope SDK to access GNSS data. And other notebooks were accessing instantaneous positions, inspecting and visualizing GNSS data, and accessing satellite geometry data using GeoLab and EarthScope SDK. And on the right panel is an example of such notebook, which shows that it contains the codes needed to run the workflows, but it also contains explanations on what those mean. My next work was expansion of tests for existing geoscience libraries in GeoLab. So some geoscience libraries in GeoLab had simple tests which just tested if the libraries could be imported or if they had a version number associated with them. But GeoLab only works if the libraries within GeoLab works. So we expanded these tests to include some real geoscience use cases. And the screen shows one such example of PyGMT, where before it was just checking if the library could be imported and its version. But now we expanded the test to include and check if the PyGMT could really plot a coastline and if that file existed and it contained the right plot. And my other work revolved around documentation and articles. So I created this documentation, how to set up SSH authentication when accessing GitHub or GitLab in GeoLab. That's shown on the left panel. And on the right panel are some articles that I wrote on GNSS reflectometry and the present geodesy technical short course. So to summarize all the work that I've done this summer, I built a set of geodesy notebooks that took the users all the way from data access to data visualization and also helped create templates that future users of GeoLab can use. I then expanded GeoLab's test coverage for geoscience-related libraries and made sure that the GeoLab environment is stable in terms of the geoscience libraries. And on a personal side, I gained end-to-end experience on how to execute a cloud project, from creating technical roadmaps to a finished workflow on how to execute the project and deliver the project. And I also picked up some skills that will stay with me even beyond the internship, and skills I can take back to my research in my university and in my future career as well. And yeah, these are the numbers. Like I created 5 notebooks, 3 documentation and articles, 9 pull requests in the EarthScope GitHub repositories. I was fortunate enough to get the opportunity to attend 3 technical courses, which are not just relevant for my internship, but also for my research. And I also got an AGU abstract out of my work this summer. And finally, I'd like to thank everyone that I interacted with at EarthScope, and I had the opportunity of working directly with at EarthScope, especially my mentors, Tammy and Sarah, for making this whole internship experience very amazing. Data services and engagement team, including the internship team, for making the internship experience very smooth. And I'd also like to thank my fellow interns and everyone from EarthScope. Thank you.
Nice work, Ishan. Thank you so much. Okay, excellent. Eshanta, take a peek at the chat. There's maybe some questions coming in for you. And we will move on. We have Destiny is up next. Destiny also served on the data services team this summer, and she worked with Omid and Rob. Destiny, you're welcome to take it away.
Thank you, Kelsey. Hello, everyone. My name is Destiny, and my internship project explored whether PassOft applications could run in cloud-based environments such as AWS. So this project came about as EarthScope continues moving more of its services and workflows to the cloud. Making PassOft one of those services could create another opportunity to make these tools easier to access, especially by reducing the amount of software users have to install and manage on their own computers. So first, some quick background on PassOft. It's a collection of 24 applications that support workflows involving seismic instruments and the data they collect. These tools help EarthScope staff and external users inspect, correct, and validate seismic data. So it includes both command line tools and traditional desktop applications with graphical user interfaces. Currently, users have to install and manage PassOft on their own computers, and this involves creating Python environments, installing dependencies, performing updates, and troubleshooting issues themselves. So because these programs were created as computer applications, my project asked whether PassOft could still run in AWS as cloud-served applications without changing their existing code. Because if that were possible, then users could focus more on their work and less on setting up the software required to do it. And fortunately, the answer was yes. My findings showed that PassOft can run on a virtual server in AWS and be accessed through a web browser. This is possible using technologies such as Docker and VNC. Without going into too much detail, these technologies can work together to make it possible to recreate a desktop environment within a web browser. It's not exactly the same, but it's a similar concept as to how you might emulate playing a PlayStation 2 game on a Mac or Windows computer. As part of my research, I created several working prototypes to explore what this experience could look like for users. And the first prototype I made used a landing page that displayed the available PassOft applications. So a user could choose an application that they wanted to use, click its launch button, and it would then open in a new browser tab. And then the second prototype I made provided an entire browser-based Linux desktop. So the PassOft applications would already come pre-installed together, and users could launch them by clicking the icons on the desktop, similar to how you would open an application on your own computer. I looked at some other approaches as well, but for the sake of brevity, these were the two that I wanted to share. And fortunately, they demonstrate that existing PassOft applications could run successfully in AWS with no change to their code. Throughout this internship, I gained hands-on experience with several technologies. I learned how to build and manage Docker containers, create and manage EC2 cloud servers on AWS, store container images in Amazon ECR, configure browser-based remote desktop using VNC, and compare different cloud services and deployment approaches. Additionally, I learned that prototyping is valuable not only because it proves what can work, but it also reveals the questions that still need to be answered before an idea can become a reliable, production-ready solution. For example, making sure it's secure, scalable, maintainable, and cost-effective. But fortunately for us, those are questions for another day. Thank you so much for listening to my project presentation, and thank you to everyone at EarthScope who supported me throughout this project. I'd especially like to thank Omid and Rob, who were a tremendous help and wonderful mentors throughout this internship.
Thank you, Destiny. That is a lot of work. Very productive. Awesome. Okay, keep an eye on the chat. Looks like some questions are coming in for you, Destiny. And we are moving right along, right on time, a little bit ahead of time. This is great. Cher, you are up next. Cher worked this summer with Jillian Haberly, who's on the engagement team, and also Mike Brzezinski from Miami University.
Wait, sorry, I forgot how to unmute myself after I started
You got it.
presenting. Okay. So I am on the wrong slide. Don't know how that happened. Hold on.
Other way.
There we go. I mean, I thought I was pressing the right arrows, but it didn't like it. Okay. Hi. So I am Cher, and I am a junior at Wellesley College studying astrophysics and geosciences. I graduated from community college last spring in astronomy, physics, and math, and that's my daughter there with me for my graduation. I'm a NOAA Hauling Scholar. And prior to this, I was a self-taught software engineer. I actually dropped out of high school. I was a seismology skill building workshop intern this summer. And I actually entered into the EarthScope family because I took the SSBW in the summer of 2024 to find how to apply my software skills to my new future science career. I got invited to be a TA last summer, and then that materialized into the internship this summer, which I think has made a very big difference in terms of what I contribute to the team. So if you're not familiar, the Seismology Skill Building Workshop is a free 12-week scientific computing summer workshop, and it's about 5 hours a week. It provides the community with computational seismology computer skills, and the participants are made up of undergraduates, graduate students, and professionals. And importantly, related to my getting into it, 30% are non-geo. So like I said, I was in like an astrophysics major previously, and 30% of our participants are underrepresented minorities. And some research that the team did and presented and has presented shows that there's a connection between the expectancy value theory, which is essentially like the fact that it is a very low barrier to entry in that it's not financial, it's over the summer, it's remote, and also it's like open to a lot of different people. You're able to reach an audience that classes aren't necessarily that students are reaching those classes to learn these skills otherwise. And this actually started in 2020 during the COVID pandemic because we needed a way to teach skills. And so this was born, and growth has tripled since 2020, which is pretty amazing, and even more so in the past few years. So the goal of my internship was to help modernize the seismology skill building workshop. As you've heard, we're moving into the cloud and into with GeoLab. And so the goal is to bring the seismology skill building workshop both into EarthScope's Moodles with the other technical courses that we have, and then also onto the GeoLab. So there were some challenges that came along with that. Which is that some of the technologies that are used do not run on the cloud. They were available in our previous platform, but not in this one. And that opened up a kind of other side of things where it if we already have to update it, like what else can be updated? So one of the things that we have found is that students are very, very interested in learning Python and about cloud computing and using Jupyter notebooks. And currently that is introduced much later towards the end of the program. And a lot of students fall off before that and are asking a lot of the time during, when are we getting to the Python? When are we getting to the Python? And it makes sense that that's happening because if you look at Jupyter Notebook usage on GitHub, it has grown 170%. And on top of that, Python has actually been shown to be a much better entrance into scientific computing for students than most other programming languages and platforms because things in Python are much simpler and much more easy to access because of the environment that is around it. So another part of that, what we're talking about in terms of like what you can do with Python and in the workshop is active learning. So during the summer, I attended the Earth Educators Rendezvous at the University of South Carolina with some people from my team. And I got to learn about in-person active learning. And I went to 3 different active learning workshops where we built an activity or participated in an activity around active learning. So I did one in, you see in this photo, we were doing a very complicated topic in atmospheric science. And I was able to understand how doing things like this, such as like if you're in a lab, help create knowledge in a much different way that makes the student a participant. And one of the concepts we use to build the seismology skill building workshop is Bloom's taxonomy. And I found that these two things are very much intertwined. So the SSBW brings active learning online, and that's something at the conference that a lot of people were very concerned about how to do in the workshops that I was in, because a lot of the stuff they do is so physically based. And as you can see from this graph here, you can see that the proficiency in these quantitative tasks and programming are much higher at the end. So these sorts of things actually work. And in the SSBW, we address the shortcomings of being online by having a Slack where students can interact with each other and actually help each other, mentor each other through problems instead of TAs or an instructor guiding them along. And that's actually how I ended up getting invited to be a mentor and then a TA, or excuse me, a TA and then an intern. And there are webinars that are synchronous every week, but we post the recording. So students can get that instructor, professor, TA, etc. community feeling that's synchronous during the video, but they also don't have to do that. So it really helps reach a lot of people. So I've gone way over. But the new flow for SSBW also involved changing things, not just to being the topic, the science or the technical topic, but then also finding ways to more interweave it into different field topics to reach more people in different fields. One of the things I've learned through this internship is that geophysics is a lot bigger and more encompassing of the geosciences. And as we heard earlier, even listening to whale sounds. So finding ways to introduce the tools and teach the tools that also show that there's a lot of different ways that we can apply them. And lastly, so I talked about some of the tools that we currently use that we cannot use elsewhere. And one of those tools was SAC, which is a seismology analysis tool that runs from the desktop. It can't run in our GeoLab cloud environment. And so we started out like, we need to find a replacement for this. We couldn't find one. And eventually that led to building something on top of a tool that was open source that worked. And this is an example of that tool. And so here's just some different, I made a GIF of using the tool and then of an example of another sort of plot, the spectrogram shown in the tool. And I really want to thank everybody within EarthScopes, the NSF NGF, my mentors, of course, Mike, who is not here, but I'm sure will listen later. I have learned so much. I feel like I have made such a big difference, and it's really ingrained in me like how important becoming an educator is. Thank you.
Thank you, Cher. Luckily, we are ahead of schedule, so your little bit of extra time was okay. Great, great work. Thank you. All right, taking us home, we have Gabrielle. Gabrielle's mentor was Beth Pratt-Situla on the engagement team. And you are welcome to take it away when you're ready.
Awesome. Thank you so much, Kelsey. As Kelsey mentioned, my name is Gabrielle. I was EarthScope's Educational Resources and Data Intern this summer. I worked under the mentorship of Dr. Beth Pratt-Situla. And when I'm not an intern at EarthScope, I am a former high school earth science teacher, now at Virginia Tech pursuing master's degrees in geophysics and earth science education. But today I'll tell you a little bit about my work this summer developing open access resources for geophysics education. So there were multiple projects I worked on this summer that varied in scope, but for brevity today, I'm just going to focus on my larger deliverables, including some web pages that cover topics under what is geophysics, as well as my contributions to some undergraduate learning modules in the Geophysics Tools for Societal Issues collection, and then I'll briefly go over some other projects at the end. So if you've ever wondered, or maybe a student has asked you, what is the ellipsoid or what is the geoid, you are in luck. And as our SciComm interns mentioned earlier, EarthScope already has a large variety of web pages that answer these questions, in addition to multiple others under that What is Geophysics umbrella. And this summer, I had the opportunity to revise 3 of them, specifically the shape of Earth and reference ellipsoids, the geoid and receiver measurements, and the visualizing reference frames with the GPS velocity viewer pages. So these pages were revised for clarity, removal of jargon. I added some practical examples, created some new figures for them, like the one that you see right here, and then also updated some older figures so that they render better on screens and also match the text nicely. In addition to those 3 web pages, I also created an entirely new web page that serves as an overview of seismology, as well as multiple near-surface geophysics methods for an undergraduate audience. And this is embedded within the Geophysics Tools for Societal Issues collection, or GETSI collection, as I'll refer to it from here on out. You can see on the right side, there's a couple of the modules. There's 17 in total within the GETSI collection, and these are all aimed at undergraduate audiences, and they each apply geodetic and geophysics data to real-world problems. Something to note is that these are not necessarily designed to be student-facing. While a student could work through them on their own online, these are designed with the instructors in mind to review the materials, download them, and implement them however they see fit in their own courses at their institutions. So that brings me to my next topic, which was my biggest project of the summer, revising 2 of these modules within GETSI. So the first one that I worked on was the gravity and magnetics module. This was originally released in 2023, and there were some differences in the technical level required of students throughout this, across from one unit to the next within this module. So my work primarily focused on scaffolding and differentiation to ensure that it could still be implemented in an introductory level course, which was the original intention. In addition, I also tested and integrated a new magnetometer app and then made some smaller revisions for things like accessibility and branding. So here's just one example that I pulled where you can see students are being now walked through the derivation of the equation for gravitational acceleration in the page on the left. And then that's tied into the later unit to kind of provide some scaffolding and help them think back to the observations they're seeing in the data and tie that to the equation. And then in addition, here's some callouts where scaffolding was added to answer some common student questions. I also revised one other module within GETSI. This is the electromagnetism module, also within the field collection. It actually has not been released yet, so you're getting a little bit of a sneak peek, but it will be revised, or it will be produced soon, so keep an eye out for that. It was already field tested by the time I arrived at EarthScope, so the bulk of my work on this module covered reviewing the materials, reviewing comments from students and teachers during the field testing or instructors, and then wrapping those into what will end up being some of the final revisions for the module. Some other projects I worked on throughout the summer in smaller ways include the Educators in Action Curriculum Studio Workshop, the Math You Need majors modules online, and I also help to maintain the Teaching Geodesy webpage. So looking ahead, my biggest takeaway from this internship was that great educational materials aren't necessarily the ones that won't be adjusted at all by instructors before implementation. Sometimes I was thinking that if an instructor has to change it, it means that there was more work that could have been done on the front end. But by the end of the summer, I realized sometimes it's best to create materials that are simply easy to adapt for instructors, because then they're able to think about the students and modify them as needed. So I'll definitely be taking this with me. After I finish the internship, I'll be returning to Virginia Tech to finish my degrees, and then I hope to teach after graduation. So some big thank yous specifically to my mentor, Beth, who it was so wonderful to work with all summer, in addition to the EarthScope Learning Solutions team, our program leaders, Kelsey, Becky, and our collaborators at Getsy and the Math You Need. Thank you so much.
Excellent. Thank you, Gabrielle. I'm seeing lots of conversations and Q&A in the chat, which is fantastic. But we do have a little bit of time here at the end if we would like to do if anyone has questions they'd like to ask in a live format. I also have a few questions of my own, but I would like to provide the audience some time to ask questions first.
I have a question.
Thanks, Donna.
And this is for any of the interns. So, working remotely can be challenging, right? And what I'm curious about is what mechanisms or tools or processes did you find most beneficial to be able to collaborate with the people that you needed to work with?
I'll answer. I would definitely say Slack. And I think that's partially because a lot of the other tools that are used are integrated into it. So there was a couple of times where I was added to like a meeting, for example, but for some reason I didn't get an email or like an invite in my email to it. But because it got automatically added to the Google Calendar, Slack notified me when the meeting was starting, and so I didn't miss it because of that. And yeah, there's just a lot of, I think, that sort of thing there that really helped me a lot.
Thanks.
I can also respond. For the comms team, we had daily meetings every morning, and so it was, up to an hour, but as long as we needed, just to ask questions in person, because sometimes there's some stuff that you just can't quite communicate over Slack. And so it was really nice to just have that routine, be able to talk, face to face with our mentors every day and with the other interns. And that was really helpful for me personally.
Yeah, that's great.
I have a question, and I will direct this to, let's see, who haven't we heard from in a little bit? How about Destiny? I am curious, what new skill are you most excited to take from this experience?
I think just using AWS like more proficiently, like using the EC2 instances for like different things, maybe my own projects. I think that'll be fun.
Awesome. Anyone else want to share?
I can share a little bit. So one very important thing that I wanted to learn and have learned during this internship was like Docker management and making a Docker itself. That means like packaging up all your environments, and you can just run your own software or own code using those environments. And I think that is very important for me actually, because I produce a lot of code and I put it into the end of the publication, and sometimes like people can access the code but they cannot run it into their own workstation. So yeah, so learning about Docker was really helpful for me especially. Yeah.
Thanks, Asif.
I could add, so I already had some experience with Illustrator and animation and video and those sort of things, but not in a scientific context. And so I think actually the thing that has been perhaps the most beneficial to me long term has been like the script writing of it, to distill these big topics into, you get 3 minutes. I think maybe everyone should have to do that for their AGU presentations, but I think it's like a really good exercise to take you want this much information to get out there and you want it to be understood. How can you say it as simple as possible and figure out exactly what the prerequisite knowledge is that's necessary for conveying that idea? I think it's a really valuable exercise.
Got time for one more question? How about a really easy one? What was your favorite part of working for EarthScope this summer?
Obviously, meeting all of you and the other interns. You guys are amazing.
So the networking.
I'll add something. I feel like we also got to try and to do so many different things. And like, I think a lot of our mentors tried to give us some agency over what projects we took on. And everyone was very receptive to our ideas, it seemed, throughout the summer. So that was very cool.
Anyone else? Favorite part?
I'll add one more thing, tagging along of what Gabrielle said. The agency part is so true. And it really gave, I think, a lot of us the opportunity to explore things that perhaps we wanted to or were interested in, but never had the time or space to. This is really special. And I wanted to plug our intern spotlights. If you want to hear more projects of what everyone's working on, check out all the intern spotlights on YouTube and Instagram because we get to hear about all the interesting work that they've been doing in really great detail and depth.
Okay, I just want to say one more thing. I just thought about how at orientation, one of the topics where we talked about like what we were hoping to get out of the internship, a common thread was like feeling like they contributed something meaningful to be a part of the team. And I definitely feel like I'm a part of EarthScope. Like it's a little weird that it's ending because it feels like, no, it's not. And I kind of got that everybody else felt like they really made a meaningful contribution to the organization as well.
100%. That's a great summary. Okay, and with that, we are at time. Thank you all so much for attending. I did have just one more quick slide to share. If I can, here we go. So thank you, EarthScope, obviously for making this possible, and the NSF for the funding. Thank you all the mentors who took the time to really get to know your interns and help them improve their working skills. Thank you SMT for providing the resources to your staff to be able to make these internships possible. Obviously, we couldn't do it without our finance, administration, and business team and budget team who keep us all paid, and that's important. Contracts and IT for all of their behind the scenes work, and the internship team for supporting all of us. And if you are interested in hosting an intern, please reach out. Thank you all and have a great weekend.